Go.
Hi, this is Nick Wanklin, demonstration of my independent study for Dr. Faddis. Let's walk around and give you an idea of what we got here. This is the Sato FG20. It's a 4-stroke gasoline airplane engine I'm using for the mule motor in essence, running a 15.4 prop. Basically, this is a little stand I built so that I could test all this. What you see here is the spark control module that came with the unit. Standard spark plug, wire and plug. What you see here is just some controls for my radio, and then the battery pack to run the controller. Runs on, I guess, what you call weed eater gas. It's a 20% mix of fuel. For the first part of this independent study, or actually the second part, but I'll show it first, we started with the temperatures, and this is the LabVIEW module that I'll be using for the final product for my master's project. Basically, the only thing I have in there now is a thermocouple module, as you'll see here. This one here is a thermocouple measuring head temperature. Basically, where it's connected is to the spark plug, around the spark plug, and then another one for exhaust temperature. As you can see, it's up in the exhaust, and they both connect back to the module. I'm running LabVIEW. I don't know if you can see on the computer, but basically there's two temperatures there. The exhaust temperature is 77 degrees and the head temperature is 109. I had it running just a minute ago, but as soon as I start it up, you'll see these temperatures change. So I'll go ahead and fire it up. I get it running. Can you go over here and show those temperatures on the screen? You don't have to right now, just when I get it running. I think you see the temperatures rise just like they should. Nothing too crazy about that. What next I have is the spark controller that I built using the Basic Stamp 2. And I'm going to go ahead and pause and get that all hooked up. So bear with me. Okay, for the second part, or the first part, whichever you want to look at it. Basic Stamp 2. Basically what this does is it's interrupting the signal from the spark controller and the crank sensor. This is a Hall effect sensor. It connects back to their module. So basically what I did was I intercepted this with this rat's nest of wires here. Basically what I'm doing is I'm taking that signal back to the Basic Stamp, where I actually delay the signal to the spark controller, in essence retarding the timing. And what I have here is a switch, and I put the long wires on it so I wouldn't have to be close to the prop. But basically what I do, it would not start on the Basic Stamp because it wasn't getting a signal and then sending it back fast enough. So what I'm doing is I'm actually starting it on the module and then switching it back over to the Basic Stamp is what I'm doing. So real quick, I'll show you how this kind of works. This is the glare, I apologize, but I added a debug in the routine so I could show you on the window. Right now you'll see a value of 1, and I'll go ahead and adjust. If I can hold this steady and adjust at the same time. The input, you see it goes from 10, 11, 12, 13, 14, 15. Basically, that's the percent advanced or retarded. Actually, 0 is top dead center, and 1 is 1%, 2, 3, 4, 5, and so on. And I'm doing that with the dash pot. That you see here, that's on the basic stamp board. So I'll go ahead and set this back to 1 and get rid of my debug and re-download to the computer. Sorry. Okay, now the fresh download into the base stamp. Now I will get my assistant and get the motor started again. Okay, so right now it's running on the controller. I'll switch it over to the basic stamp. That's run on the basic stamp. I can hold the RPM steady and go to I don't know if that was very clear or not, but switch position, basically green to black is the running off the controller, and then red to black is running off the basic stamp.